Something strange is going on aboard one of NASA's most iconic spacecraft of the 20th century. Voyager 1 is a verified space soarer that has flown for nearly half a century and is still going strong. But it is sending NASA an unusual message, and they are trying to figure out why. Is it maybe the work of some extraterrestrial being? Let us find out. Welcome back to Cosmos Observer, and today we will be covering our hot topic on the mystery data sent back by NASA's Voyager 1 from beyond our solar system. 45 years after its launch, NASA's Voyager 1 is still traveling beyond our solar system. However, the seasoned spacecraft is suddenly returning unusual data, perplexing its engineers. The Voyager 1 spacecraft's technical crew is attempting to solve a puzzle. The interstellar explorer is functioning correctly, receiving and executing commands from Earth as well as accumulating and returning science data. However, the probe's attitude articulation and control system outputs do not match what is going on board. While the probe is still working, readouts from its Altitude Articulation and Control System, or AACS, do not appear to match the spacecraft's movements and orientation, implying that the ship is unclear of its orbital location, according to NASA. The Voyager 1 spacecraft is now traversing interstellar space. In 2012, it went over the heliopause, which marks the end of the solar wind's dominance in space. The spacecraft, however, remains within the gravitational clasp of the Sun and has not yet departed the solar system. Scientists expect that as Voyager 1 approaches the end of our solar system, it will leave its garden and travel further into space. However, the further it travels, the older it becomes. It is now 14.5 billion miles away from Earth, having traveled across space at a rate of around 3.6 Earth-Sun distances each year in recent years. Voyager 1 was launched on September 5, 1977, 2 weeks after Voyager 2, its robotic twin. They initially moved in the same direction to meet up with the outer planets, but after swinging by Saturn in 1980 and 1981, they diverged onto opposite paths. The 45-year-old spacecraft's orientation is controlled by the AACS. It keeps Voyager 1's high-gain antenna pointed precisely toward Earth, allowing it to broadcast data and other information back to Earth. The AACS appears to be operational, but the telemetry data it is returning is invalid. For instance, the data could appear to be generated at random or not reflect any likely AACS scenario. The AACS keeps Voyager's antenna pointing directly towards our planet, allowing it to give NASA data on the surrounding interstellar environment. A puzzle like this is sort of par for the course at this stage of the Voyager mission, according to SUZANNE Dodd, a project manager for Voyager 1 and 2 at NASA's Jet Propulsion Laboratory. Dodd claims that the probe can detect when something is wrong. Things could happen as Voyager 1 passes past the border of our cosmic lake, where the Sun's magnetic field interacts with the interstellar medium in ways that are still unknown. This area is rich in astronomical data that has yet to be tapped. Voyager 1, which was launched in 1977 to research the outer planets of our solar system, has outlasted expectations and continues to send data back to Earth. The pioneering spacecraft crossed interstellar space in 2012, leaving our solar system. It has already covered 14.5 billion kilometers since leaving Earth. According to NASA, Voyager 1's AACS is providing arbitrarily produced data that does not represent what is truly happening on board. Even if the spacecraft's system data indicates differently, the antenna appears to be properly oriented, as it is receiving and executing NASA commands as well as sending data back to Earth. It added that the system problem has not caused the aging spacecraft to enter safe mode, in which it only performs necessary activities. Voyager 1 appears to be collecting and returning science data correctly for the most part. It receives and executes commands from Earth, albeit sending and receiving messages takes around 2 days because of its considerable distance from us. We know the antenna is still pointing toward us since we are still in connection with Voyager 1, despite the unusual nature of the telemetry data readings. The problem is with the AACS aboard Voyager 1, which keeps the spacecraft and its antenna in the appropriate alignment. And the AACS appears to be operational as the spacecraft is receiving commands, acting on them, and transmitting science data to Earth with the same signal strength as before. Despite this, the AACS is providing garbage telemetry data to the spacecraft's operators. The most remote human-made object from Earth is Voyager 1. Beyond the connection lag, working with a system that is so far away and that was developed so many decades ago has numerous obstacles. The voyage of Voyager 1 has already faced difficulties. The spacecraft's primary thrusters began to exhibit indications of wear and tear in 2017. On Voyager 1, the engineers switched to thrusters that had been used during the mission's planetary contacts 37 years before. It is just another illustration of the Voyager spacecraft's incredible longevity and smart design. It would not be the first time the Voyager crew had to rely on backup equipment. When the primary thrusters on Voyager 1 began to fail in 2017, engineers moved to a different set of thrusters that had previously been used during the spacecraft's planetary contacts. Voyager 2 continues to operate normally at a distance of 12.1 billion miles from Earth. JPL designed and continues to operate the Voyager spacecraft. Caltech's JPL division is based in Pasadena. The NASA Heliophysics System Observatory is supported by the Science Mission Directorate's Heliophysics Division in Washington and includes the Voyager missions. Both Voyager probes, launched in 1977, have lasted far longer than mission planners expected and are the only interstellar spacecraft capable of collecting data. The data they offer from this region has contributed to a better understanding of the heliosphere, the hazy barrier that the Sun produces surrounding our solar system's planets. Each spaceship produces around 4 fewer watts of electrical power every year, limiting the number of systems it can run. The mission engineering team has shut down numerous subsystems, including heaters, to save power for science instruments and crucial systems. As a result of the declining power, no science instruments have been turned off yet. The Voyager team aims to keep the two spacecrafts operational and return unique science beyond 2025. Scientists on the mission will continue to make the most of the data coming down from the spacecraft's unique vantage point, while engineers focus on solving the mystery that Voyager 1 has presented. Even though system data implies otherwise, NASA's technical team has determined that the spacecraft's antenna is aligned. It is receiving and executing commands from NASA and relaying data back to Earth. Engineers may be able to remedy the problem through software adjustments or by employing one of the spacecraft's redundant hardware systems once the team has identified the source of the problem. If they cannot pinpoint the source of the issue, they may have to learn to live with the inconsistencies. The team will continue to monitor the signal to see if the incorrect data is coming from the AACS or another telemetry data creation and transmission mechanism. Until the nature of the problem is better understood, the team cannot anticipate how long the spacecraft will be able to acquire and send science data. The team can steer the spacecraft, which, when combined with the strength of the signal and the lack of fault protection activation, indicates that Voyager 1 is in good shape. However, the telemetry signal does not make any sense, Dodd explains, yielding either all zeros or the number 377. NASA stated that it cannot predict how long the spacecraft will be able to gather and transmit science data until the cause of the problem is better understood. Dodd and her colleagues are trying to figure out what is causing the Earth's robot emissary to relay garbage data. Dodd pointed out that the engineering team is facing some big challenges regarding this case. One significant difference is that light takes 20 hours and 33 minutes to get to Voyager's present interstellar location. Thus, a round-trip message between NASA and Voyager takes 2 days. However, Dodd reassured us that if there is supposedly a way to solve this issue with the AACS, they will find it.